Hey guys, welcome to another video on generative AI. So in this we will continue the same BERT model where we have fine-tuned the BERT model with the context. So we will see the same thing over here, but we will overcome one of its limitation. So let's get into it. So first we have taken the same model. We have taken a BERT model. We have initialized its tokenizer and the model itself, and this is the our function which will be used to predict the output based on the question and the context provided. So let me explain you this function. In this code section, the tokenizer takes the raw text and converts it into numerical input IDs. Crucially for Q&A tasks, it joins the question and context together, usually separated by a special token like a SEP, so the model can look at both simultaneously. In this code section, this code tells PyTorch not to calculate gradients, which saves memory and speed up the process since we are only predicting, not training. For this part of the code, the model outputs logists, that is the raw scores, especially it provides start logists and the end logists for every single token in the input. For this piece of code, the model doesn't just know the answer, it predicts which token is most likely to be the start of the answer and which is most likely to be the end. So this softmax activation functions turns the raw logics into a probabilities between 0 to 1, and this max, that is a numpy function that will pick the index of the highest probability. Then we have this confidence score. It calculates a simple average of the start and end probabilities to see how sure the model is. This slicing, it grabs the range of IDs from the start index and the end index. Then we have this piece of code which will decode, that is, it converts those IDs or the token IDs back into a human readable string. Then we have this if condition which will help in handling no answers. In many Q&A datasets, if the model can't find an answer, it points the start and end indices to the CLS token, the very first token. This check ensures that if the model points to CLS, the function returns none instead of junk text, and at last we return the response. So here we are using this function, giving it a question and the context. This is a context and it is giving us an output with the confidence score. Start ID is this and the end ID is this. It is just a substring from this big context, and same goes with this one. And if the model doesn't find a relevant answer to the question, it will just return a none. That is a CLS that we have discussed while explaining this function. So here we have one limitation. So this model just takes it has an input sequence of length 512 tokens, which is this 512. So if the token exceeds the limit of 512, it will give a runtime error. So in our previous context, we have just 497 tokens, and in this example we have approximately 1059 tokens. So how can we overcome this situation? So one solution for this limitation is using the truncation argument as true. That will, when it reaches a maximum length of 512, it will just truncate it, means it just take that 512 tokens and it will make decision, or it will return the text based on that first 512 tokens, and it won't consider the rest of it, the tokens or the rest of the substrings. So this is what we have done, and it has provided a none answer because the answer to this question is in the context which has been truncated. So we can take from 4000 till the end of the string, means we will slice the context and provide it to the model and get the answer, which we will get as over 100 million. So another solution for this limitation is chunking, that is splitting this whole string into substring and giving this substring to the model and getting the answers. So here we have an example of chunks sentence. Like we have this many sentences. Here we have this as a whole, but here for an example we have taken the sentences. So the example of chunking is we will create a chunks, that is a batches of the sentences or sub sentences. Like if we do this one, we have a first batch, second batch, third batch. If we want a chunk of 4 sentences, then we provide a 4, and the overlapping, how many sentences it should overlap. Like for example, in this we have taken the 3 substrings and an overlap of 1. That means first 3 sentences or substrings and the 1 string or sentence will get overlapped. Like this sentence 3 is getting overlapped. If we want to overlap 2 sentences, we can provide it as 2, and the last 2 sentences will get overlapped. So this overlapping ensure that the context, the main idea of the context should not be lost while training the model. So we use this function, this code. So we have this code. So first we will make sure this all our sentence, which was this big sentence of 1059 tokens, is converted into a substrings, where there we have made it as a substrings. So we will splitting this whole context into substring based on a new line. So here we have a 19 subsets. So then we are doing chunking of this one, and we take the 3 sentences, chunking of 3 sentence, making a batch of 3 sentence and overlapping with a 1 sentence. Then we have a set of questions, and we will storing this answers of this question in this dictionary. So in this code we will take the first batch of this chunked sentence, and then we find the answers to this question from the first batch. We find the answer to each of these questions and store it into this answers dictionary, and we do it for all the batches that has been created, this 19 batches. And if we have 2 answers to 1 question, then we check score of the latest answer is greater than the previous one that has been stored in this dictionary, that will be updated with the latest one. And here we have the answers to all these questions and overcoming the limitation. Thank you for watching, and make sure you subscribe to this channel so you don't miss out on the future updates on amazing generative AI contents. Thank you for watching.